In this video, we're going to start talking about the difference between linear and exponential functions. So let's just recap linear functions. A linear function has the general form y equals mx plus b, where m is the slope and b is the y-intercept, or the initial value. And with a linear function, the slope, that m value, is constant. That tells you how much the function is going up for each unit that it goes over. And what makes a linear function really special is that it's the only function in all the world, in all of math, that has a constant slope. So a linear function goes up or down by the same amount every single time. It has a constant slope, and that's what makes it special. When we're talking about growth, we say that some situation has linear growth if it's changing by the same fixed amount every single time. So if it's going up by $10 every time, or if it's going down by 100 people with each unit of time, whatever it is, it's changing by the same fixed amount. In contrast to that, an exponential function changes by the same relative amount, i.e. the same percentage. So if we're seeing a situation where something's gaining 10% every day, or something's losing 8% every day, that's an exponential growth. So again, the difference in linear, it changes by the same amount. With exponential, it changes by the same percentage. We model an exponential function with this q of t function, and it might look scary, but it's really not that bad. So q of t just stands for the quantity at some time t. Q naught, that's the q with little zero down beside it. We say that's q naught. That represents our quantity at time 0. That's why we've got the little 0 to represent. That's our quantity at time 0. And then we multiply that times 1, either plus or minus our rate. And this rate is the percentage written as a decimal. So if we're growing by 10%, we would write it as 1 plus 0.10. Again, that 10% we write as a decimal, 0.10, to represent the r. Or if we were losing 5%, well, 5% as a decimal is 0.05, so we would write it as 1 minus 0.05 there in the parentheses to indicate that we're taking away 5%. So again, r is the percent change written as a decimal, and then t is just time. So let's look at an example comparing these two. So we're going to have two savings plans. In the first one, we're going to deposit $1,000, and then this account is going to pay us $100 in interest each year. In plan B, we're going to deposit $1,000, and this plan will pay us 10% interest each year. So we want to look at how these two accounts grow, and particularly look at how much money will we have after 5 years. So here we have our first 5 years. Again, time 0 is the initial value. That shows we put $1,000 into savings plan A and savings plan B. And then savings plan A, we add $100 each year. So it's going up from $1,000 to $1,100, $1,200, $1,300, and so on. You can see it goes up by 100, the same amount every single time. And at the end of 5 years, we're up to $1,500. For savings plan B, we're going up by 10%. So if we take the 1,000 and multiply it times 1 plus 0.10, that's adding 10%, we get 1,100. If we multiply that 1,100 again by 1 plus 0.10, we get 1,210. So the first year, 10% of 1,000 was $100, so we added $100. But now we have $1,100, and 10% of 1,100 is $110. So we go up by a little bit more. Then we increase it by 10% again, and 10%, and then 10%. You can see after 5 years, we're at $1,610.51 compared to $1,500. That's over $100 more in savings plan B. So in this case, it's far more profitable to increase by 10% each year rather than $100 each year because we end up with more money. So savings plan A, it's growing by the same amount per year. It's growing by $100. That is classic linear growth. So we would write its formula, our amount based on the number of years. We're going up by 100 each year, so that's the 100 times n, and then plus 1,000 because that's our initial value in the linear function. So that linear function is our slope times n plus $1,000 for the initial value. For savings plan B, we're increasing by the same percentage each year. We're going up by 10%. Since it's a percentage change, that's an exponential function. So our balance in account B, based on the number of years, We're going to put our initial value first. We started off with $1,000. So that comes first. Then we have our parentheses. Then 1 plus our percentage written as a decimal. In this case, it was 10%, so we write that as 0.10 to the n. So you can see these are our two different models, and then we could plug in the number of years and see how much money we have. So we could plug in 5 for n in both equations to get the last row of our chart.